In this video, we discuss how to obtain the equation of a tangent line in generic form. Let's first start out by remembering how we get the equation of any straight line. Here's a typical straight line, and suppose we know something about the coordinates of a point on that line, as well as the slope of that line, which is the ratio of the height to the distance moved along that line. Now, if we take any point on that line whose coordinates are x, y, then we know that the difference in the y coordinates divided by the difference in the x coordinate, that's exactly what we mean by the slope of that line. To get the generic equation of a straight line, then, we simply manipulate this to obtain y equals m x minus a plus b, or in an expanded format. Now let's look at a generic function. Suppose this is the function y equals f of x. And let us look at a particular point on that line. Suppose the coordinates of that point are x naught, and the y coordinate would be the function evaluated at the point x naught. We're going to glue a tangent line right to that point, and that line has the following property. So it's tangent to the curve, which means that the slope of that line is going to be equal to the derivative of the function at the corresponding point at which that line is glued. Furthermore, it goes through the point x naught f of x naught. So going through exactly the same steps, any point on that line will satisfy the fact that the difference in the y coordinates, y minus f of x naught, divided by the difference in the x coordinates, x minus x naught, has to be the same everywhere, namely has to be equal to the slope f prime at the point x naught. We can manipulate this to put it in a more convenient form, but this is essentially the equation of the tangent line already. In the more convenient form, we can rewrite this as y minus f at x naught equals f prime at x naught times x minus x naught. We can bring this over to the other side, and when we do so, we obtain y equals f at x naught plus f prime at x minus x naught.